Hello Internet, welcome to Advanced Geometry. Today, we are going to learn about volume. Yes, you heard me right, volume. Well, you can pronounce it in two ways. You can say volume, which is the most common way of saying it in the Philippines, thanks to the Americans of course, or you can say it volume, the Harry Potter way. But no matter how you pronounce it, it still means the same thing. Volume, or should I say volume as per Wikipedia, is a quantity of three-dimensional space enclosed by a closed surface. For example, the space that a substance, solid, liquid, gas, or plasma, or shape occupies or contains. The volume of a container is generally understood to be the capacity of the container, that is, the amount of fluid, say gas or liquid, the container could hold rather than the amount of space the container itself displaces unless specified. Right now, we will be discussing the volumes of different solid figures, namely prisms, cylinders or cylinders, pyramids or pyramids, no, don't go that way, cones, and spheres. Let us start with the volume of prisms. A prism is a solid figure whose bases or ends are the same size and shape and are parallel to one another, and each of whose sides is a parallelogram. We name our prisms according to the shape of their bases. A triangular prism has triangular bases. A rectangular prism has rectangular bases. A hexagonal prism, that's right, you know the drill, has hexagonal bases. One common example of a prism is a box, which is actually a rectangular prism. It has two identical rectangular bases that are parallel to one another, surrounded by four parallelograms called the lateral faces. To find the volume of a box, we just simply need to multiply the length by the width by the height. As we have learned previously, the product of the length and the width gives us area. Thus, the volume of a box can be calculated as a product between the area of its base and its height. And it works with any prism out there, maybe a triangular prism, a square prism, or hexagonal prism. This formula surprisingly works with cylinders too. You see, cylinders are special kinds of prisms wherein two bases are identical and parallel to one another, and a curved parallelogram surrounding the bases. Only that cylinders have circular bases. Since cylinders are similar to prisms or prisms themselves, then we can apply the same formula on finding the volume. So volume equals area times height. The area of the circle is pi r squared, or pi times the square of the radius. Hence, the volume of cylinders is pi r squared h, or pi times the square of the radius times the height. Next, we will be looking at the volume of pyramids. Pyramids are solid objects where the sides are triangles which meet at the top or the apex of a single base, which is a polygon or a flat shape with straight sides. The diagram to the upper right is a square pyramid, but there are also triangular pyramids, pentagonal pyramids, and so on. In this video, we have two containers. One is a square prism and the other one is a square pyramid. As we can see, the bases of both containers have equal area. Also, both containers have the same height. The square prism container is filled with a liquid using the square pyramid container. It then takes three square pyramid containers to completely fill the square prism container. It means that the volume of pyramids is just 1/3 the volume of prisms. Thus, the volume of pyramids is equal to 1/3 times the area of the base times the height. Let's talk about our last two solid figures, cones and spheres. Cones are solid three-dimensional figures that has a circular base joined to a point by a curved side. Think of a cone as a pyramid with circular bases. Its lateral face, when unfolded, looks like a pie with a curved base. Spheres, on the other hand, are three-dimensional geometric figures where all points on the surface are of equal distances from the center. You can think of a basketball as an example of spheres. To find the volumes of cones and spheres, we need to compare them to the volume of cylinders. In this video, we have three containers: cylindrical, conical, and spherical containers. All of the containers have the same or equal radius. The heights of the cylindrical container and conical container are equal to the diameter of the spherical container. A liquid is then poured to the cylindrical container using the conical and spherical containers. As we can see, the amount of liquid from the conical container accounts 1/3 of the entire volume of the cylindrical container. Also, the amount of liquid from the spherical container accounts 2/3 the volume of cylindrical container. Since the volume of cylinders is equal to pi r squared h, and the volume of cones is 1/3 pi r squared h, or 1/3 times pi times the square of the radius times the height. This also means that the volume of spheres is equal to 2/3 pi r squared h, or 2/3 times pi times the square of the radius times the height. but the height of a cylindrical container is equal to the diameter or twice the radius of the spherical container. Thus, the volume of spheres is equal to 4/3 pi r cubed, or 4/3 times the pi times the cube of the radius.